Hi, hi, Mark.
Hello, Sai. How are you?
I'm great. How are you?
I'm good. Good. Thank you for having me. I'm very excited.
Thank you for giving me opportunity to interview you for my YouTube channel and podcast.
Sure, my pleasure.
So I thought to tell about you and the work that you are doing to my audience.
Sure. Um, I can start. So my name is Mars. I'm a CNCF ambassador. I try to help CNCF with organizing KubeCons. I work as a program committee member, volunteer. I volunteer with organizing meetups here in Dallas, Texas. I try to do all other activities and wherever I can, however I can to help. My day-to-day job, I'm a systems engineer at a company called KGPCo. We do integration and consulting and all of the cloud stuff with telco operators, mostly AT&T, Verizon, and T-Mobile. So that's my day-to-day. I'm a lab guy, and lab and cloud guy basically there. So that's my life.
So you're from?
Well, originally I am from Kyrgyz Republic, Kyrgyzstan, which is in Central Asia. It used to be part of Soviet Union, but right now I'm in Dallas, Texas, which is quite far away.
So what is CNCF?
CNCF is the Cloud Native Computing Foundation. It's an organization which is part of Linux Foundation, and CNCF is basically an organization that tries to promote everything cloud native, and it handles a lot of open source project, cloud native open source project. The most famous is probably Kubernetes, but we also host Prometheus. We also host OpenTelemetry. There are more than 100, maybe now 200 projects at CNCF right now. So it's a huge foundation with lots of people.
So what you do as a ambassador?
As an ambassador, I try to organize events in Dallas area. I try to promote cloud native tools, cloud native meetups, cloud native products, basically be a good citizen, try to engage people, show them how they can contribute to CNCF, how can they help with with Kubernetes stuff, all that stuff. Um, it's kind of fun. I'm also supposed to write blog articles and videos and all that stuff, but I'm not very good at that.
And your full-time job is network engineering.
Network engineering and systems engineering. I think my official title is like senior systems engineer, something like that. But yes, I do everything. I do everything. I do. We're a very small team, so I have to do everything, which is great actually. I like it a lot. So I do. I try to. We build servers, server racks. We install OpenStack or Kubernetes on top of them. We deploy solutions on top of them. We do demos. We integrate ready solutions for customers. So it's a lot of very diverse work, a lot of very, it's every day is basically different. Every week is different from every other week, which is great. It's great if you like hardware, software, and if you like variety.
So what was your previous job?
My previous job was with Nokia. At Nokia, I was doing, again, very similar work. I was doing in the lab 5G radio, cloud radio, basically, when you were trying to deploy 5G base station software on top of OpenStack Cloud. I think we use Red Hat OpenStack, but we can use vanilla OpenStack or Nokia flavor OpenStack. It was fun. It was a lot of different products, a lot of different crazy requirements, especially for 5G because you have a lot of bandwidth and very strict requirements for latency, for many other legal stuff. You have to. Um, it's very challenging at sometimes, but it was also a lot of fun. I also spent a lot of time in the labs back at Nokia trying to virtualize everything we could, all kind of VNF that Nokia has. Nokia is a huge vendor, so we have a lot of VNFs. A VNF is a virtual network function. It's a fancy name for virtualized, let's say, switch or any networking component. You virtualize it let's say, old school MSC, MSS like hardware, which you use to connect, operate your 2G network or 3G network. Now it becomes a virtual machine, and in the cloud era, it becomes a VNF when you basically define your virtual machine and you define interfaces and how it's supposed to operate and run. So it's also, it's nice, it's a progress, it's inevitable. Telco is a very conservative industry area, but the progress is inevitable, so we are going there. And Nokia is one of the leaders, so I like it that a lot.
I can see presently you are doing two different works and too many works. How you are able to do that?
I'm sorry?
I can understand you are doing two different works and too many works. How you are able to do that?
Well, it's not really too different. Well, I mean, they are somewhat related. I have a very understanding manager, which is great. I'm very happy about it. But yes, I basically volunteer about 4 to 8 hours of my work week to CNCF. I try to do more if I have availability and time. But generally, you don't need, if you don't work full time as a contributor or developer for CNCF projects, you still can volunteer and you can still help with some basic stuff, some, I don't know, low effort things, attend some meetings. You don't have to spend like multiple 20 or 40 hours a week to do that. There are many areas we can help even with 1 hour per week. So I try to do that. And also you don't have to code to contribute and help. You don't have, I'm not a programmer, I'm not a developer. So I mostly do non-code contributions. You can do documentation, you can do seek contrabacks stuff, you can do a lot of different stuff basically. As long as you, the best way will be to, if you want to get started and help, the best way will be just to join Kubernetes Slack or CNCF Slack, ideally Kubernetes Slack, and join the SIG contrabacks channel. And you can be just ask, hey, how can I help? And people will direct you and they'll ask you, hey, we need help here, we need help there. You can start doing reviews, you can start joining the meetings. People will start to trust you, and then you will get your whatever you want to, however you want to help and volunteer and do, you can do that. It's not very difficult.
So, what CNCF is doing?
Well, right now, CNCF is doing a lot of different things, multiple, in a lot of areas, but mostly CNCF is sponsoring, providing a platform for projects, for open source projects, providing marketing tools, providing a lot of opportunities for projects to engage, organizing KubeCons and Cloud Native Cons, which are also huge industry events. We had like, I think like 10,000 people, 12, 15,000 people physical on KubeCon EU and KubeCon North America, and another 10 or 20,000 virtual attendees. So these are huge events. KubeCon, CNCF is also organizing a lot of marketing stuff for projects, a lot of different things basically.
So you are a systems engineer and you are into this position from a long time. So how do you feel? What do you do?
As a systems engineer, I mostly, well, it's basically same technologies change, your stack changes, but the principles stay the same, kinda. So in the past, it was just plain Linux systems or plain Windows or VMware, ESXi. Nowadays, it's more. Then it was OpenStack everywhere, especially in telco area. It's very, very, very common. You cannot avoid it, and even if you want to. But I like OpenStack. It's a great software. And nowadays, it's last few years, it's Kubernetes everywhere. As a systems engineer, you basically just deploy operating systems, deploy on top of hardware, on top of servers, and then you deploy and configure your cloud solutions on top, I don't know, either Kubernetes or OpenStack, or anything that, any platform basically, any orchestrator. And on top of the orchestrator, you usually, it doesn't matter if it's OpenStack or Kubernetes or anything else. They're not the same, they're completely different. But generally, the idea is you deploy some piece of software on top of your operating system, And after that, you deploy your actual workload, your actual piece of software that you want to be running. In the case of OpenStack, it will be virtual machines. In the case of Kubernetes, it will be some Helm chart, or it will be some kind of container, either your own deployment or something that you get from a vendor. It's multiple options again. It depends on what your manager asks you to do, basically, what kind of things you want to do and show. And it's not the end goal. It's more like a tool to reach to where you want to be.
What do you like in your job?
I really like the freedom. I like to the freedom. I like to the freedom to do what I want, however I want. It's still fun. It's a lot of fun, and it's also a lot of fun when you're troubleshooting some things and you don't know what's happening, what's wrong, some minor issue. Is it a faulty cable or faulty, I don't know, misconfiguration in some YAML file or in some configuration file, or maybe some bug somewhere. And when you try to troubleshoot and when you check all the kind of logs, you do tracing, I don't know, you take your TCP dump just to understand what's happening, and then you understand what's happening and you solve it, and then you feel very smart. Because usually sometimes it can take a few days or even weeks to find the root cause of some problems. If they are tricky or if they are very deep inside the stack, it can take forever. So that's what I really like. You can still feel this. It's kind of you get paid to solve very interesting problems, which is what I really enjoy to do, which is what I really like to do. So my hobbies, like I have my labs at work and I also have my home lab, which is again I'm doing the same stuff for fun at home, very similar, because I like to do it.
Do you have any particular experience that you cannot forget in your present job?
Uh, Experience that I cannot forget. Like, what do you mean? Like, is it positive, negative?
Yeah, any experience that you cannot forget, any particular incident or any problem that you have solved?
Okay, yes. Let me think for a moment. Yes, we had a very interesting case where we had a new deployment for one of the operators with very expensive, very fancy 400 gigabit per second fiber channel cables. And those cables are, of course, they are new and untested. Well, they are tested, but you wouldn't. It was new for me because I would never have thought that the problem was in SFP firmware. And SFP firmware, we had to replace SFP firmware and SFP and firmware inside the NIC for HP servers, or was it HP or Dell servers? Basically, the problem was so far deep below, because when you insert the cable, usually you have the green lights, everything shows green, it means the cable is engaged, the link is up and active. We had that, but we had no traffic, and we couldn't troubleshoot. We couldn't understand why. We checked every tweak. We was thinking it was a very complex deployment. We had like 20 or 30 different boxes interconnected with those expensive cables. It couldn't come up. It wouldn't come up. We didn't know why, what was happening. It took us, I think, 4 or 6 weeks engaging Cisco, engaging our operator, engaging a vendor for our fiber cable. In the end, we found the problem with it was in firmware, and it was really deep below the stack, below everything I have ever touched, very close to hardware level. And that's one of the downsides when you're working with very new, the latest the very latest, greatest available, I don't know, the highest available speeds, the most expensive you can buy stuff. You have very high speeds, yes, but you also get some random problems like that, where things go very wrong for reasons you cannot control.
So, what you find interesting in your job?
Um, many things. I like servers. I like hardware. I like OpenStack. I like Kubernetes very much, a lot. I like the freedom to deploy them in any combination I want. I like to deploy I like the freedom to troubleshoot when things go very wrong, and they often do. Very often they go very, very wrong. Um, yeah, I really my management a lot. We have a very great manager who's very understanding and very, very supportive. Um, a lot of things. I like the opportunity to travel. I like the opportunity to engage with other people. Yes, it's. I think it's mostly positive experience. I cannot say that I'm unhappy with my job.
You said you write articles.
I'm supposed to write articles, but I don't do it as often as I should, and I should do it a lot more often. Luckily, we have a lot more people who do it much better than I do, and much more often than I do. But yes, generally we are supposed to promote cloud native tools, cloud native projects, um, try to explain to people how different things and how different options and tweaks, knobs, and it changes work. What was like, for example, their most recent, maybe not the most recent, but the most um, difficult probably, and yeah, difficult and not very well spoken change, not very well covered change was when in Kubernetes we decided to remove Docker shim layer, and it caused a lot of panic among users because they had thought that the Kubernetes will stop supporting Docker completely, which is not the case. It just wasn't communicated properly, and a lot of bloggers and journalists were very quick to um, write articles with some wrong, perhaps maybe not wrong, but not very clear messaging. So a lot of people were like, "Hey, what's happening?" A lot of questions. So we should do that much better, I guess. Much more earlier. Engage with people, with bloggers. I don't know. Uh, yeah, something like that.
So what you don't understand something in your job?
Oh, a lot of things. A lot of things. I'm still learning. I'm still learning every day. Like every day. That's what I like. That's what I also like. That every day you feel like, wow, this is what's happening. Wow, you learn something new every day, or at least every week. It depends how busy you are. But uh, a lot of things are still not clear. I still have no idea how to, for example, work with eBPF. Like eBPF is this new exciting technology, which is kernel level. It's a extended Berkeley packet filter, but just eBPF or just eBPF nowadays. It's how you can come run basically your applications, your user code very, very close to kernel and with very high speed. And you can do that very securely, and you can intercept any Linux system calls. You can do a lot of crazy stuff with it. Like, I know Cilium works on that from Isovalent. They use eBPF underneath. A lot of monitoring tools are using eBPF underneath. A lot of security tools are using eBPF. I know some basics. I know some basics. I know some basics. I can write probably some very simple eBPF one-liner, but to understand it better, to understand more of it, I would love to do that one day. It's a lot of fun. Um, it just takes time to learn it more, learn it better, let's say. And when you don't do it 24, well, not when you don't do it full time, it's kind of difficult to learn it better when you don't engage it with it. I still don't, there are a lot of things I'd love to learn. I don't understand open telemetry, for example. I'd love to learn more about open telemetry. I think it's a great, a fantastic project, and I would love to learn more about it and how it works and how do you engage with it, how to work with it. Um, it sounds, I think it's like it's going to be the future of all telemetric, of all the open source telemetry projects. Or I hope it will be. I'm not sure. I'm not qualified to say that. Uh, we will see. Um, a lot of there are 200 projects, maybe more, close to 200 projects under CNCF, and I know maybe only quarter of them and the best day. So there's a lot of projects which I would love to learn more about.
Is it important for you to know programming to do your job?
It's very helpful, but it's not a requirement. Like I can. it helps if you know programming, you can automate your job basically. If you know some basic shell scripting, basic Python, uh, then you could automate a lot of things for your job. You can write some scripts to automatically do this, do that. Generally, you don't have to know programming. No, I'm more a systems administrator guy. I don't know. Don't really do full-time programming. So for me, it's more like a combination. If I can automate my job, I do that. If I do not know how to do it, I don't have time, or I don't want to, or it's easy to do it manually, I'll just do it manually. But generally, yes, if you know it, it will be. If you know programming, life will be much, much easier for you. And you can also troubleshoot it much better, which is also helpful.
So, what's your background, educational background, and how it is helping you to do your present job?
My educational background, I have a master's in electrical engineering. So I was studying telecom networks. At the university, telco networks. I was studying everything related to telco, and I'm a telco engineer by education. So it was kind of it's I would say it's a requirement when you work in the telco industry. Perhaps not 100% requirement, but it will help you a lot when you have a telco background. Not because you are required to have it, but it will help you with understanding how systems work, how they operate, what are the basic requirements for redundancy, reliability, like N plus 1, N plus M systems, like 5 nines, all the traditional telco stuff, which is again very conservative. Normally, it's very conservative, as it should be, just like finance. So it helps a lot. I would say it helps. It helps. Perhaps not every day, but fundamentals, they do help. And another thing is that telco, your generic education, your higher education, it also gives you a very solid platform. Like you can understand, hey, you can work with wireless networks, with, I don't know, cell phone towers, I don't know, with mobile networks. You can work with 5G, MSS, MSC, that kind of stuff, core network, radio network. But you can also get engaged with fixed networks, with your providers, with your ISPs, which is like, I don't know, building your data center networks. It's all very, very closely related.
So, what are the things that helps if you learn that helps to do job better?
Linux. I would say Linux. If you're not, it was one of mistakes I've made in my life, and I regret about it, but that I did not start engaging with Linux as early as possible, because a lot of things are running on top of Linux, whether it's Red Hat or Fedora or Ubuntu, Debian, whatever operating system, it doesn't really matter whatever flavor you choose. But if you learn as much as possible, if you learn how to configure it, how to troubleshoot it, how to work with it, how to configure networking, how to do traces there, how to do, I don't know, TCP dump, how to, I don't know, compile kernel if you are closer to advanced level, that kind of things. They will help you a lot. How does kernel scheduler works? What is out of memory situation? Why it is, and what will kernel do in that situation? It will help you a lot because whether you like it or not, either OpenStack or Kubernetes or whatever will replace it in the future, they will be using Linux under the hood. And when you know the platform, when you know the basics, when you know the foundation of what everything runs on, your life will be much, much easier. And I think it's generally quite helpful to learn Linux as well, because most people use Windows or Mac OS, which is great. They're both great in their own ways. I really like them too. But Linux is just what you will be doing for your job. And if you're going to work in that area, you should probably learn it much more, much better.
You work on cloud technology.
Yes, yes, I work with OpenStack a lot. I work with OpenStack. I do not work with AWS or Google Cloud directly, unless we are like asked by some vendor or we have some demo, but my day-to-day job is mostly OpenStack, involves OpenStack very often, and the reason is because a lot of telco workloads are running on top of OpenStack. For many operators, they cannot run their switching software, their equipment on the cloud. They have to, even for legal reasons, for compliance, for legal, for the tradition, they have their own data centers usually. So they have their own data centers, they have their own hardware, and when you have your own hardware, you run OpenStack, and on top of OpenStack, you usually run your workloads, telco workloads, your, I don't know, your application servers, your IMS, HSS, all kind of crazy VNFs, MME, I don't know, whatever you want to run, you usually run on top of OpenStack. There are ways to do it on top of VMware and ESXi and VMware, and there are vCloud, and people do that. Some operators go that route, but majority, I would say 90% of operators, maybe more than 90% of operators go with OpenStack. And it's cheaper, it's free, it's open source, it's very customizable. You can tweak it however you would like, and if you want support, you can use it on your own, or you can get OpenStack from Nokia, or probably from Ericsson or Huawei or ZTE, some other vendors, I'm sure, or you can get it from Ubuntu, from Canonical, or from Red Hat, from Mirantis. Different flavors if you want to have paid support and some technical support, or you can do it yourself. I believe Walmart, I think Walmart still runs their OpenStack, and they don't pay anyone to support it. They just do it internally, which is actually amazing and really great. They have really great team. Many other companies do it also internally only.
So what is the toughest problem that you solved?
Toughest problem, well, there are many, there are so many, I don't know where to start, but if it's technical, then probably it will be networking. Networking inside Kubernetes, networking inside OpenStack is also difficult. If it's higher level, like my day-to-day job, if it's higher level problem, like it will be probably generally deployments of those solutions and delivering them on time. Another layer, like human layer, it will be just engaging with people, teaching people how to do it, teaching people how to operate it, learning from them, I don't know, interacting, finding people who can help. It's, yeah, it depends on the layer you want to talk about it, but generally there are multiple problems on every layer. Something like that.
So what are your qualities that are making you to solve problems?
My qualities, I would say I am curiosity. If you are curious, I think it will help you a lot to solve problems quicker or faster. If you want to know more and more, if you want to dig deeper, there is actually a troubleshooting technique called 5 whys. When you face a problem, you just ask why something is happening, and why something is happening because of this, and then why is this happening, and then you dig deeper until you reach like 5 layers, I don't know, or more. Like try to go to the root cause, and not only eventually you realize that not only you have to solve the problem and the root cause and cause the issue, but you also have to make sure that it will not repeat again. And what do you have to change? What do you have to do? How do you have to what you must do to avoid this problem in the future again, because that's really unfortunate when you have the same problem again and again. It's not very helpful. So you have to change the process, you have to change the documentation, you have to change instructions, you have to change some software perhaps, well, just to avoid this problem in the future. Or you have to write really good notes and root cause analysis, so people will not do this step again and again. Yeah, it's I would say curiosity will be number one quality.
So you're a systems engineer. While doing this work, have you ever thought that this has to be changed in order to solve a lot of problems?
Yes, 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 many times. Many times, yes. It's a lot of things are outdated, or perhaps not as good as they should be. Um, Even right now, like say we are at work, when we are working doing some stuff, a lot of stuff is done manually, and I know they can be automated, and they should be automated. And it's only the question of time and resources, and the question of dedication, basically. If we have enough free time or downtime to just sit together and replace this particular set of steps with some script. Uh, like for example, one of the tasks I have to do is to reboot some server or some white box solution, and then I have to go into BIOS, change some parameters, and then reboot it again, and then go into some grab menu, run some commands. This happens very often, and you can do it automatically with Python and expect. And I wrote some scripts to do that, but I'll still need maybe a few weeks of time just to test the script, because it's when it works on one machine or two machines, but it has to work on multiple, maybe it has to work on hundreds of machines all the time without any hiccup. Otherwise, you are just wasting time. So that will be my next step, just to automate this and check it, make sure it works, troubleshoot, maybe tweak some timers, tweak some settings, add some safety precautions, like don't do this until you see that. Don't go into BIOS if the box is not responding properly. Don't exit BIOS if you did not make this change properly, this kind of stuff. Don't run this command if you haven't confirmed that the BIOS is okay and properly and changed settings as there. A lot of things like that should be safety checks, which are like basics, but they take time, so you need to do that. It's mostly time. Well, as always, every work is like that, I guess.
So what are your resources to study?
I have many. I have many. I have recently discovered O'Reilly Learning subscription, which is kind of expensive. I think like $40 per month. I'm not sure, at least in US. I'm not sure if it's the same price in other countries and other places. But what I do really like about O'Reilly is they give you 10-day trial, I think, or 2 weeks trial at first before you start. Uh, they have a lot of great books, really good books, the newly published books, and you can read them online. Or they have also sessions. They have video courses, trainings. They have live sessions with experts, where you can engage with an expert and ask them a question. If you have whatever you're trying to learn, is it cloud native stuff, Kubernetes or Helm, or I don't know, Service Mesh, or if it's something more, I don't know, more traditional, like I don't know, Google Cloud, AWS, or Python, or Red Hat, I don't know, administration stuff. So I like that a lot. My other resources will be just normal Twitter or Hacker News, or some blogs I'm subscribed to in RSS. There is an also LWN, Linux Weekly Journal, I think, or Linux Journal, I'm not sure, but it's lwn.net, which is a great magazine about Linux and everything about Linux. It's very, very interesting as well. A lot of times there are very deep discussions and very deep articles about Linux internals. Uh, and then it's mostly books. So books, trainings. You can try to learn from blog articles or from some random pieces here and there. And some of those blogs are really, really good. They're great. But generally, they will not cover everything from end to end, and they're not supposed to give you the solid like foundational and deep understanding of everything. So I strongly prefer books and video trainings, I don't know, courses, which gives you like they require more time from you, because you spend like 10, 20, 40 hours reading or going through them. But in the end, I think results are much better because now you understand what is happening, why it is happening, what parts of the systems are there. Like I had a few years experience of Linux, and I still learn a lot of new stuff from the Red Hat Linux training from O'Reilly. And I'm sure there is a lot of other trainings. There is a Linux Academy, there is edX, there is Linux Foundation trainings, which are also excellent. Highly, highly recommend. So those are really good.
What are the common issues that you see in systems?
It depends on which systems, like in what level. I'm not sure there are like anything common. Well, yeah, there are some things that are quite common, like complexity. Complex systems, they break. That's because they're complex. They inevitably they break. The only systems, my biggest complaints are usually about documentation. It's either not updated, or it doesn't exist, or it's not updated properly, or it's not very well written. It's really difficult to write good documentation. It's really I don't know, frustrating when you have a problem and you cannot find the solution. And you're trying to read documentation and it doesn't help you. It's a very common situation, and so documentation is extremely important, no matter what kind of systems are you working on. So when working internally, I try to write our stuff into our internal wiki. I try to write our, I don't know, great emails with RCAs, all that stuff, just for people to be aware of stuff and how to fix it or engage with it and what to do, how to do this, how to do that. And documentation is extremely important. It's probably more important than anything else when you're working with systems.
Your way of looking at problems.
I don't have a particular way of looking at problems. I just try to solve them if I can. If I sometimes I cannot. That's also okay. But generally, I learned it from my former manager that instead of just being afraid or trying to understand, like, hey, you have this, how do I even start? Just not be afraid, just start and do something. Try to get logs, try to have some scientific hypothesis. There are ways to engage it scientifically, like, hey, you have the hypothesis, you test it, you change it, and then you confirm whether it worked or not. There are different ways to troubleshoot, but basically do not be afraid to engage. Do not be afraid to just start doing it. Start reading, going through logs, going through traces, going through, I don't know, some metrics. If you have some Prometheus Grafana metrics and you're not happy with them, like try to understand what's happened, why, etc., etc. Just engage with the problem, and very often it goes away. Once you start digging deeper, it goes away, or at least you have an understanding that what is the problem is actually about, why it is happening, why it's not working, or the root cause, or at least you understand where it is located, let's say, which area, which particular element is faulty or misconfigured.
Communicating with people or communicating with computers? Which one is easy?
They're easier. Each one is difficult or easy in their own way. I would say with computers, it's easier to communicate with computers because you have usually a CLI or GUI, and you just do stuff, and they usually respond back with output, and it's much. You can Google a lot of things a lot of things with open source. What I like a lot is that most of your problems in open source are already solved, or at least they have a lot of open source and openly available documentation, logs. You're very likely not the first person to face this problem or this issue. That's not the case when you're doing with private vendor stuff. Very often, that's not you cannot find anything in Google. With people, it's also difficult sometimes, because when you have time zone differences, you might have cultural differences when people expect you to do stuff, or you expect them to do stuff and they do not do it, and they do not understand the urgency. It might be some priorities issue, it might be some, I don't know, communication issues. So there are challenges in every way, but I would not say that it's different between communicating with people or communicating with computers. They are just different ways of communication. Like, it's your day-to-day job, basically. And the more experience you get, the more you communicate with people, and the less you communicate with computers, basically. Well, at least it was in my experience. Like in the past, I used to do computer stuff like almost 90%, 95% of time. Nowadays, I mostly do maybe 50%, 70%, I don't know, depends. But I do a lot more communication with people, with, I don't know, demos, try to engage with team members, I don't know, management, all that stuff, with CNCF folks, with anyone.
So at last, CNCF ambassador, what is your observation about my work and about my question in this conversation?
I liked it. Thank you for the interview. It was really interesting. It was really nice to reflect back, to think about general stuff, because when you do day-to-day work, you dig deep inside and you forget about big picture. So your questions allowed me to remember, like, hey, there is a big picture. Maybe it will help someone who is just starting, or maybe it will help someone who has completely different experience to say, hey, you are being wrong, or yes, this is correct, this is not correct. I don't know. But I like the picture. I like your questions. So thank you for asking them. Thank you for having me. I appreciate it. And thank you for engaging. Thank you.
Have you seen any videos of mine on YouTube?
No, I'm not using YouTube very often. I'm not using YouTube very often, and I haven't had chance to see your videos yet, but I will.
Yeah, actually, I did a master's in software engineering and bachelor.
Nice. You, I'm sorry. Your audio looks like is breaking down. I cannot hear you. You appear and disappear for a few seconds. I can see you.
Can you hear me?
Yes, now I can hear you. Yay, great. And now I cannot hear you again. I'm so sorry. I guess it's Skype's. I hope you can hear me. And I guess it's Skype's way to tell us that, hey, we should probably round up. Yes, thank you so much for having me. Thank you so much for the interview. I really appreciate it. I hope we will have a chance to do it again sometime in the future. And maybe next time I will interview you, or vice versa. We will see. Because I would love to hear your opinions about your questions. I'm sure they were very deep and very interesting. So thank you for them.
Can I put this video on my YouTube channel with your permission?
Sure, of course. Thank you.
And also, can this audience part?
I'm sorry, but the answer is yes. I couldn't hear the last part.
Can I put this audio and video clip everywhere?
Yes, of course. Yes, of course.
Video marks.
I'm sorry again.
And thank you, Mars. Keep going.
Yes. Sure, my pleasure. And thank you for the interview. I really appreciate it, Sai. Thank you. I hope to see you someday in real life, and we will have a lot of chat, a lot of talks, and very deep conversation about everything.
Sure.
Thank you, Sai. Thank you. Bye.